In this video, I'm going to explain how you solve a trigonometric equation, and there are simple steps that you have to follow. Step number one, if you are given a trigonometric equation that contains different trig ratios, let us say there is a cosine and then there is a sine and a tangent, whatever, simplify to one trig ratio. You're going to rely on your trig identities to simplify the equation into one trig ratio. What I mean here is there will only be cosine or just a tangent or just sine in that equation. That is the first step. Then you solve the equation. What I mean here is you solve the equation until you have something like let us say cos x equals to a, where x is your unknown that you're solving for and a is a constant, which is, in other words, something like cos x equals to maybe 0.6. That is what I mean by solving the equation. Then from having this, you move on. You're using the arc function to get what we call a reference angle. If you press something like arc cos 0.5 on your calculator, what you get there is not necessarily the final answer. Sometimes it may not be the answer. What you get is called a reference angle. And using the reference angle, you can deduce more angles according to the question. Because sometimes the question says the angles should fall within a certain domain or within a certain range. You should follow that, and you're going to rely on your reference angle to deduce more of the angles. I'm going to start here with a very simple example of a trig equation. So we call these trig equations if there is a trigonometric function involved and an unknown. That is what we call a trig equation. Trig equation or trigonometric equation. I'm just shortening this to trig equation. If I have an equation like cos theta or cos, let me say cos solve, the question says solve for theta. Solve for theta, where theta, all right, let me write this. This is what we call the, where you should find, like it's a range given or a domain given where you should get your theta values, or where all the theta values should fall from. They said 0 degrees is less or equals to theta, which is less or equals to 360 degrees. What they are saying here is that your answers must fall within this given range from 0 degrees to 360 degrees. That's where you should find your theta. All the possible values of theta should be given, not just one. If there are two values in that fall within that range, you should find all of them. If there are 3, you should find all of them and get that would be a complete answer. Now the question here is, it's a simple one. It says the cosine of theta is equals to 0.5. We start here. You're going to rely on your calculator. So the step from here is to get what we call theta using the arc function. So this is arc, we call this arc cos. This is the arc cos 0.5. We punch this arc cos 0.5 in our calculator. Since our theta is supposed to be in degrees, you make sure that your calculator is also in degree mode. So I punch arc cos 0.5 in my calculator. I get theta equals to 60 degrees. 60 degrees. What I got here is what we call a reference angle. So this is a reference. We are going to use our reference to get more of these angles. The trick here is to know that one, this ratio here, cos theta, is 0.5 and it is positive. From our cast diagram, we call this a cast diagram. Let me just draw a sketch of a cast diagram. We did trigonometry, you will know this diagram, where we say in the first quadrant, so this is quadrant number 1. Okay, let me call this quadrant number 1, quadrant number 2, quadrant 3, and quadrant 4. In quadrant 1, all of these ratios are positive. Cosine is positive, sine is positive, tan is also positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cosine is positive. Now, if we know that our cos theta is 0.5, which is positive, it means the angles that we're looking for fall in the first quadrant and the fourth quadrant. So here we're going to the first and fourth quadrant. This is where we're going to get our answers. They're coming from the first and the fourth quadrant. Now, in the first quadrant, obviously our answer there will be an acute angle. It will be less than 90 degrees. It's from 0 to 90 degrees. It actually means in this case, theta, one of the thetas that we're looking for, is our reference. So our reference is actually one of the answers. So theta is equal to 60 degrees, comma. Now you look for another answer. So 60 degrees is from the first quadrant. Now let us find another angle in the fourth quadrant. In the fourth quadrant, the theta there will be 360 degrees minus your reference angle minus 60 degrees, which means it is 300 degrees. This is the second answer, such that our solution set, we give our answer here as a solution, as a set. So I'll write here solution set. Theta, this is the set. It contains 60 degrees and 300 degrees. Then you close this. There is no more. We don't have any other answer to look for because of our range. It is between 0 degrees and 360 degrees. Let us say we wanted other answers. Let us say our range was bigger than that. All you needed to do is to add 360 degrees to each of these to get another answer that is also valid. But in our case, we just wanted answers between 0 degrees and 360 degrees, and we happen to just have two of those answers, 60 degrees and 300 degrees. You can check your answer by putting it back into your original equation. If you punch in your calculator cos 60, we get 0.5. If we also punch cos 300, we also get 0.5. It means we have solved our equation and we have solved it completely. This is the step that I said. This was a straightforward question. And let me do another example quickly. Now we have this example here. Cos, it says 3 sine theta. 3 sine theta is equals to 0.524. 0.524. I said the first thing that you need to do is to make sure that you have a ratio, a trig ratio equals to something, a constant. So we want to have something like sine theta equals to a, which is a constant. So the first thing that we do here, we're going to divide by 3 both sides. If I divide by 3 both sides, I have sine theta equals to 0.524 divided by 3, 0.524 divided by 3, I get 0. I'm going to keep to 3 decimal places, 0.175, 0.175. Now from here, I'm going to use the arc function, which means theta is arc sine of 0.175. I punch in my calculator, I get a reference angle. So the reference is arc sine of 0.175. We get 10.079. 10.079 degrees. So this is our reference angle. This is a reference. However, it still falls in our range because they said here 0 degrees is less or equal to theta, less or equals to 360 degrees, which means our answer should be within this range. And our reference angle, it is a reference, but it is also part of the solution. Now the other angle, we're going to do our reasoning again. Where are we? Our sine theta is positive. This is positive. So this is positive. And from our past diagram, we know that sine is positive in the first quadrant and in the second quadrant. 10.079 degrees is in the first quadrant. The answer in the second quadrant would be 180 degrees minus 0.79 degrees. So the other answer here is 180 degrees minus 10.079 degrees. We get the other answer in the second quadrant. So 180 minus 10.079, we get 169.921 degrees. And because of our range, I think we have all the answers that we need. So now we can write our solution set. So solution set. Theta is equals to a set with 10.079 degrees, comma 169.921 degrees. Then I close the bracket. This is the final answer. This is how you do these calculations. I want to point out something very important here. Let us say you had your ratio as a -1. When you punch your theta ref, this part here, if you were having negative something here, you just use the negative to deduce which quadrants you're going to find your answers in. However, in your arc sine, when you're trying to get your reference angle, always try to use a positive so that you have a positive reference angle. I'm going to explain how these reference angles work because we have 4 quadrants. So reference using the reference angle. Your calculator will not give you 2 values. It will only give you 1, which is the reference angle. So using the reference angle, in quadrant 1, quad 1, theta is equals to theta ref. So in quadrant 1, your reference angle, whatever you got, if it was just acute, it is just that. You stop there. If it is in the first quadrant, whatever you get, you stop there. Then in the second quadrant, quad 2, theta would be equals to 180 degrees minus theta ref. So in the second quadrant, you subtract your theta ref from 180 to get the theta that you're looking for. Then in the third quadrant, your theta will be 180 degrees plus theta ref. And in your fourth quadrant, your theta would be equals to 360 degrees minus theta ref. This is how you use your reference angle. Once you get your reference angle and you're looking for a value in the second quadrant, or angle in the second quadrant, you just say 180 degrees minus that reference angle. If it is in the third quadrant, you said 180 degrees plus the reference angle. If you're in the fourth quadrant, it is 360 degrees minus the reference angle. And please understand what I said. I said when you are punching your arc sine or your arc cos or your arc tan, make sure you use a positive number there. Instead of a negative number for your ratio, use a positive number so that whatever you get is your reference angle. It may not be one of the answers sometimes. It may not be one of the answers sometimes, but sometimes it is one of the answers. All right, let me do another example, especially one where we have a negative angle. All right, I'm going to use this one. It says sec theta is equals to minus 2.5. Minus 2.5. We don't have sec theta or sec what on our calculators. We have cosine, we have tan, and arc cos, all of that. So the first thing that you have to do in this case is to convert or to simplify this until it is to one trig ratio of our trig ratio that we know, the cosine, the tangent, and the sine function. So we know that sec theta is 1 over cos theta, and this is equals to minus 2.5. This means cos theta itself is minus 1 over 2.5. Or let me write it as it should be. So this is 1 divided by minus 2.5. We get our cosine of theta. We just punch in your calculator. Cosine of theta is 1 divided by minus 2.5. We get minus 0.4. So it's a negative minus 0.4. The negative here is telling me the quadrants where I should look for my answers. It tells me the quadrants where I should look for my answers. So cosine is negative in the second and third quadrants. My answers should come from the second and the third quadrant. This is what it tells me. Now, from here, let me look for a reference angle. So theta ref, the reference angle, by the way, will be arc cos. I'm using the arc function now, arc cos 0.4. Please see that I'm not using minus 0.4 when looking for my theta ref. I'm using a positive ratio here. I'm using a positive 0.4. And if I punch in my calculator, I get arc cos of 0.4, a positive 0.4. I get 66.422 degrees. This is my theta ref. Is it part of my answers? It is not, because my answers should be from 0 degrees is less or equals to theta less or equals to 360 degrees. And because I know I should be in the second quadrant and the third quadrant, 66.422 is in the first quadrant. So this is in the first quadrant. First, it cannot be part of my answers, but I need that. So let me use now my reference angles. So theta will be, the first theta is in the second quadrant, which we said we use 180 degrees minus the reference angle, which is 66.422 degrees. Then the other theta, so this is comma, the other theta or the other answer is in the third quadrant, where we said it will be 180 degrees plus 66.422. Let me clear this part. Yes, 66.422 degrees. I only have two answers here because of my range. All right, what do I get here? So 180 minus 66.422 degrees. I get 113.5. Let me use a dot for the decimal. 578 degrees. This is one of the angles. The other angle, which is in the third quadrant, it will be 180 plus our reference angle. We get 246 point, so this is 246.422 degrees. 0.422 degrees. I no longer have any other answer. Therefore, I'm writing my solution set. So this is the solution set. In other words, when you solve a trig equation, you don't have one answer. You don't just get one answer. You get a set of answers, several of them, and they should fall within the range that the question is prescribed. So in this case, it means our theta is, this is the set, 113.578 degrees. The other answer is 246.422 degrees. I close my set. These are my two answers. That is my solution. It's done. The question has been solved. Please get how you do this. Simplify to 1 trig ratio. I did that. I was here. Cos theta. I simplified to 1 trig ratio. And then I solved for the trig ratio. I'm there. Then I look for my reference angle using the arc function. I did this and I got my reference angle. Then I do this reasoning. My original ratio cos theta is negative, which means I find my angles in the second and the third quadrant. Now I'm going to use that if it is in the second quadrant, it is 180 minus the reference angle. If it is in the third quadrant, it is 180 plus the reference angle. If it is in the first quadrant, the reference angle is what part of the answers. If it is in the fourth quadrant, it is 360 degrees minus the reference angle. That's it. This is how you solve these questions. It doesn't matter what ratio it is, whether it's a tangent, whether it's cosine, whether it is sine. This is how you do it. Let me end the video here. I'm going to do more advanced examples of how you solve trigonometric equations. The important thing here is the process. You do the simplification, you have 1 trig ratio, and then you find your reference angle using the arc function. Then you use your quadrants to find the other angles. Thank you for watching the video. If you have any questions or any comments, just write in the comment section below. Otherwise, give a thumbs up and subscribe to the channel.